Welcome to the first discussion of what's been going on with Principium from the Initiative and Institute for Interstellar Studies. I'm Patrick Mahon. I'm the Deputy Editor for Principium, and John.
I'm John Davies, and I'm the editor of Principium. And what a year it's been!
Absolutely, yeah. A year in Interstellar Studies, but a weird year in just about everything else.
Yes, yeah, and yet so much has been achieved in several spheres that IFRS has been involved in, and in the wider world of interstellar studies.
Absolutely.
So let's use the Principiums from last year as a sort of basic framework. That outer solar system thing in the first issue, in the February issue, Phil Sutton from Lincoln University.
Yeah, I mean, I thought that was a really interesting article to start off the year, because obviously IFRS is all about interstellar, but if we're going to get there, realistically, we're going to be going in stages from here to there. And one of the things I really liked about Phil's article was talking about what are the targets that we might be interested in. That clearly lots of people are interested in the outer planets and their moons. But then as we move further out, we go to Kuiper Belt objects, possibility maybe of a Planet 9 somewhere out there, still under investigation by people. Beyond the Kuiper Belt, you've then got the Oort cloud. And then we've, over the last 3 years or so, from 2017, we've had those interstellar visitors, Oumuamua and Borisov, coming into our solar system from somewhere beyond our solar system. Lots of interesting things there that all help us to think about what are we looking at here and what do we need to do engineering wise to get further and further out in the solar system and get nearer to our interstellar vision.
Yeah, and that outer solar system that is a natural early objective, and there's a bunch of guys at Johns Hopkins Applied Physics Lab, Ralph McNutt and Pontus Brandt and the rest of that team, all working on their interstellar probe, they call it. It's an interstellar medium, but really it's a Voyager on steroids, and that's going to be really interesting. That's seriously high on NASA's list for implementation, so that's going to be great. Yeah, and of course there was the report from the last real face-to-face IEC. The second half, of course, because the first half was in November 2019 issue of Principium. And that was quite an event. I was the one who went there and reported back. But it was great to meet people like Marshall Eubanks and Al Jackson face to face. And Gurveer Singh as well, who the guy who wrote the history of the Indian space program. Things, busy guy. Yeah, so
it's fascinating, isn't it? Because it's all of what, a year and a half ago, and now the idea of going to a large conference and meeting thousands of other people in a small space seems absolutely horrendous. Looking back to when that was allowed and when that wasn't going to cause problems, it's always brilliant to go to conferences like this and meet these people that you've talked to on email and what have you. You've read papers of theirs, but to actually meet them in person is excellent.
Well, and you were able to be there at the previous one in Bremen.
Absolutely.
So on the May issue, we had that interview with Cassidy Cobbs, me and Robert Kennedy of the Institute for Interstellar Studies in the States, and of course she's the other officer in the institute, but she's a bioscientist, and she managed to find some time away from firefighting on the front line in the hospital she works at in New York right at the beginning of the pandemic. Amazing character. She did some interesting stuff on wheelship biology for a piece that came out at the International Space University a couple of years ago. Yeah, so she was an interesting.
Well, one of the things I really liked about that was the fact that it was a really good illustration of the breadth of things that we need, the breadth of skills, the breadth of knowledge that we need if we're going to push on with interstellar endeavor. Because inevitably people tend to think that it's all about engines, it's all about propulsion, it's all about that, hard physics and hard engineering side. But there's so many other aspects, and the biology side of it is hugely important in the long term. If we're talking about any kind of crewed interstellar travel, then clearly how the biology works is vital to that. So having someone like Cassidy on board thinking about that side of things is really important, really useful.
Yeah, and in that same issue, we had Al Jackson's piece celebrating the 60th anniversary of Buzzard's interstellar ramjet idea, yeah.
I love that. I mean, I know you and I have talked about this numerous times, but there's lots of challenges to the ramjet idea, all sorts of practical issues that may get in the way, but the basic concept of it, of being able to another way of being able to get around Tsiolkovsky rocket equation by picking up your fuel as you go, rather than having to have it all on the rocket when you start, is just so attractive and romantic. That if there's a way of making it work, it would just be brilliant.
Yeah, and if you look at the Sabre engine that the reaction engines people are building, that's a sort of similar idea, except that it works in the atmosphere.
Yeah.
I mean, and that's how a jet engine works. And that's why a jet engine is so much more efficient than a rocket, because it gets half its pressure around it.
Absolutely.
Doing the same sort of thing interstellar wise is extremely attractive engineering wise, obviously.
Yeah.
And I remember reading Tau Zero by Poul Anderson all those years ago. I guess you do too. But,
yeah.
And
actually, that was one of the things I did like about Al Jackson's article, was the fact that he talked about the physics and engineering of it, and Bussard's original paper and the follow-on papers by people like Carl Sagan, Tony Martin, and others. But then at the end of his article, he did talk about the portrayal of ramjets in science fiction. And again, I think that's one of the things that's interesting for what we do, is clearly, looking at stuff that's realistic and feasible is really important, but also seeing the other side of it, how this stuff's been portrayed in fiction is also really important, because that gives us ideas of how these things might work if they're feasible. How might they work? And that's what science fiction can be really good at, is taking a case study of something like that and saying, okay, what would it be like if people were actually in this situation?
Yeah. And then there was your piece about the fast radio telescope and the fact that it's working into the Breakthrough Listen initiative.
Yeah, absolutely. And I mean, that's become relevant again over the last few days or the last few weeks, hasn't it? Because Breakthrough Listen have announced some more, a potential candidate signal, which there's lots of discussion going on across the internet at the moment about, is this a realistic signal? Is it not a realistic signal? And, we have to be prepared for the reality that it may just be some kind of instrumental issue or something else. It's, we've had plenty of these before in SETI. But it's interesting to see that, the application of, pretty significant amounts of money and a lot of brain power to the Breakthrough Listen project has driven on SETI quite substantially in the last few years.
Yeah, and then we get to the August issue, and Richard Swallow's piece about the BIS SPACE. I'm giving the initials because it's pronounced space, but actually it's a habitat, and it's parallels with Gerard O'Neill's thinking in his book all those years ago. But clearly, that sort of a habitat has strong parallels with world ships. And there was can't remember which issue it was in, but Greg Matloff, Professor Greg Matloff, City University of New York, wrote us a letter about his idea for thermal control of vehicles like that, basically just using the fact that space is very cold.
Yeah, Yeah, absolutely.
4 degrees Kelvin, so you can just get rid of heat by dumping it.
Yeah,
The stars won't notice.
Absolutely. But yeah, I mean, it's great to see that our colleagues at British Interplanetary Society are, doing as they've done so many times in the past, doing really interesting, detailed work on one aspect of what becomes an interstellar project, which is ultimately how do you keep people alive in this environment. And things like, temperature control, clearly a really important part of the overall process if you don't want people to boil or freeze.
Yeah. And the report in 2 issues actually of the elective module we did at the International Space University. Of course, IFRS has been doing those for years, but this one had to be done remotely for the usual biosecurity reasons, and we had features from people all over the place, so I think probably the most comprehensive report we've had in Principium of one of those Masters elective modules, and I think there's one coming up this year too.
Yeah, absolutely. And again, I mean, that's great. The link between IFRS and the International Space University, I think, is brilliant for both of us, because we get to talk to and enthuse, work with their students who are all dedicated to finding out more about what it's like to work on space projects, and many of whom will become the leading space leaders of the next generation. And they gain access to a different kind of knowledge because our interstellar focus, it doesn't tend to be the focus of a lot of the rest of the material that they'll be looking at, which will be much more sort of solar system focused and Earth orbit focused and so on. So I think it's a really good way of, we get something really great from them and they get something great from us as well.
Yeah, well, I think Chris Welch has been a supporter of that, the professor there, and he's I think expanding the minds of his students is something that is clearly close to his heart, and he's always been a supporter of the Interstellar Initiative. So it's
absolutely
great working with him. I'm looking forward to going back, because I've done a couple of the sessions there face to face, and Strasbourg's a beautiful city, the students there are, generally speaking, a great bunch, and very international. Lots and lots of people from Asian countries, notably India and China, and everywhere else basically.
Yeah. No, I'd love to be able to get across there one of these days once all the current pandemic is out of the way.
Yeah,
that would be a lovely thing to do.
Yeah, we managed to get the monolith that we built for the 2014 Science Fiction Worldcon, the 2001 style monolith, across to ISU, because they agreed that they could find a home for it long term. It's quite big, 4 meters high, so it's but they've got a central atrium, so when things get a bit sorted out, that would be great to see that there.
Oh, absolutely. Yeah.
And we had a piece on FTL. Gary Bennett in that issue too, and again, may never be achieved, but a thing to keep an eye on, because if that one can be broken through, and people as eminent as Kip Thorne think that it at least it's not totally infeasible, then that's going to make an enormous difference in the future.
Yeah, absolutely. And that's, again, it's one of the things I love about IFRS is we've got the whole spectrum from, looking at detailed technical studies of, small chipsats, with a laser sail attached to them that we're actively looking to actually build and actually fly, all the way out to people thinking about, okay, what could we do? How realistic is faster than light travel? What are the technologies that might enable us to do that? What are the barriers in the way? And really, huge, big picture stuff. So I love the fact there's this big, broad range across what we do.
Yeah. Everything from Project Glowworm, the IFRS demonstrator of laser push in low Earth orbit, which the guys at the technical side are working on, right out to things like this. very speculative things like FTL. And then the November issue, we had Adam Hibbard, the mathematical brains behind the Project Lyra stuff for intercepting interstellar objects, talking about maybe doing a sample return.
Yeah,
that was a really striking piece.
Yeah, absolutely. I mean, I really enjoyed that one because so much of what we've talked about has tended to be for purely practical engineering reasons. You do a flyby because doing anything else is really complicated and takes more fuel and all the rest of it. But if you can do a sample return, as we've seen at the moment with the Japanese with their Hayabusa mission, a sample return from a comet, and others have done similar, NASA as well, and ESA as well, I think. Clearly you get so much more science if you can get the stuff back and analyze it back in the lab here. So yeah, if there's any possibility of doing an interstellar sample return, that'd just be amazing.
Yeah, well, this was just to interstellar object, but now we know we've got interstellar objects to investigate, and it means we can actually physically examine things that are from outside the solar system.
Yeah, absolutely.
Yeah. And of course, on the practical level, we great to see China doing that sample return that just came back a couple of weeks.
Yeah.
From the moon, so for the first time for several decades, so the near Earth stuff is really getting started again. That's really good to see that making progress.
Yeah, absolutely.
We have our sights set further, of course, but the fact that things are really progressing as far as basically our back door in terms of space is great news.
No, absolutely. Yeah. Absolutely.
And I wrote that piece about the interstellar downlink. That's a pretty live subject at the moment. So the problem of getting the information back from a probe out 4 light years away, particularly a really tiny probe. Not too much of a problem for something like Icarus Firefly, that Z-Pinch idea of Robert Freeland and Michel Lamontagne. Big vehicles, not too difficult to think in terms of constructing something like a big microwave dish that you can unfurl when you get there. But from something that's only a few grams at most, getting a signal back from there is a hell of a challenge.
Yeah, absolutely.
So I just did a survey piece, really. I'm no longer deep into the mathematics of that. And I don't suppose I have been since the early 70s when I left the space business. So that's a long time ago, but I've still got the basics. And
but it's a huge issue because it's one of the things that we tend to focus on other things, don't we? We tend to focus on, okay, what's the propulsion system? How big's the probe? What are the scientific instruments on it? And a whole load of other things that are all really, really important. But the fundamental question of whether you can actually get the signal back from it, so you can actually get any information from this probe. So it's gone 4 light years away to Proxima Centauri or wherever it's gone. How on earth are you going to find out what it found out if you can't? It wasn't much point in sending it. So it's an absolutely vital issue.
Yes, it's a case of Starship phone home.
Yes.
Starship, should I say? Really, it's only one is Starship phone home. Yeah. So 2021. I'm working on a February issue of Principium already, and we've got 3 really interesting pieces. I think, maybe 2. It depends how big it gets. We've had some really big issues. I mean, we were 92 pages in November, and slightly more in August, and we've been well over 50 pages right the way through. So, and we don't want to make it into a massive great tome, so we might postpone 1 or 2 things. But I think the things that are definitely going to be in the next issue are a very long distance idea from an old friend of mine who's a fairly bright physicist, way beyond my level in physics terms. who's got an idea for a meeting point, which he calls a Treffpunkt, stealing from German for a meeting place, somewhere between our galaxy and the Andromeda Galaxy N31. Yeah, very, very long range stuff, but speculate on real physics. And Michel Lamontagne's piece on world ships and self-replication. Yeah, and we had a piece from Olivia Borg last year as well, which I didn't mention, which was about the self-replication project within IFRS.
Oh yeah, that's true. Yeah,
yeah. She's also contributed to the report on the virtual IAC.
No, I'm really looking forward to seeing Michelle's. I'm looking forward to seeing Michelle's piece in the next article.
Well, he got it to me about a week ago, so that's more or less ready. It's just for me to do the layout and the editing. So rest of 2021, what are we looking forward to?
Well, I mean, I suppose one question is, what more might we find out about our interstellar visitors that we've already talked about a couple of times, Oumuamua and Borisov? You know, there's been so much both, you know, theoretical speculation about, you know, what are they, particularly Oumuamua, because it's so many unusual aspects to the observations of it, and more theoretical work trying to go on, you know, what else, how frequent might these be? How frequently might we see other typical interstellar visitors? When's the third one going to turn up, etc., etc.? And that provides lots of opportunities for us in IFRS in terms of the question of, if a third one turns up, or a fourth one, or a fifth one, how quickly can we build the mission, get the mission out there, and go and see one of these, go and actually sample one of these, as Adam's piece was talking about. There's lots of potential stuff there, I think, in terms of interstellar visitors.
Yeah, and that's been of great interest to astronomical societies. I've done several talks with astronomical societies, all remote, of course, in the last 12 months, and in fact, specifically on Borisov and on Oumuamua, as well as the interstellar topic generally. And I was talking to York Astrosoc just a couple of days ago. And also to Leeds Astrosoc. They're both in Yorkshire. Why isn't there anybody from Lancashire? Oh. That's where I come from. Yeah. Well, all these Yorkshire amateur astronomers seem to be very interested in this, and of course, it really crosses over between their interest, which is anything that's up there that they could potentially point a telescope at, or some of them are also amateur radio astronomers as well, and the interstellar thing. So that's fired quite a lot of them up, I think. So I'll be looking forward to talking to more astronomical societies and schools as well, also next year, in the coming year. Yeah. So it's been pretty good. It's been not so nice for the human race in general.
No.
I'm hoping for a better year, but it's not been too bad at all for
it's lovely actually to look back on the last 4 issues and just see what a range of topics and authors and issues that we've covered, and it just reminds me that, you know, there's an awful lot going on in this field at the moment, and an awful lot of people who've got interesting things to say about it, which is what makes working on Principium so much fun.
Yeah. Okay, well, here's to the coming year, and
absolutely. And yeah, P32 will be out in end of February, won't it? So
thereabouts, yeah.
Keep your eyes out, everybody, and hope you'll be excited by what you see. If you've got anything you want to talk to us about, or that you want to write for Principium, get in touch with John, get in touch with myself, and we'd love to hear from you. We'd love to have new people writing for us.
Yeah, well, always looking for good new material.
Absolutely.
Yeah. So
but for now,
that's it from us.
Yeah, absolutely. So yeah, happy New Year, everybody, and we'll hopefully catch up with you all soon.
Yeah. Okay.
Cheers. Bye.
Cheers. Bye.